Now we're going to try these capacitors as a charge pump. So there's a charge pump circuit here and an oscillator circuit here. And I'm going to want to load the charge pump with a load. And I have this glue gun here, which is going to be the load. I suspect that the resistance in the heater of the glue gun might change with temperature, so I'm going to measure the resistance when it's hot and cold. So it's cold right now, and we'll just measure the resistance in its cold state. 503 ohms. So we'll have to remember that, because I'm going to measure it once it's warmed up by the circuit. Okay, we're testing the charge pump with the polymer capacitors in it. And if we turn on the voltage here, at 12 volts, the output voltage will go to 46 or 47 volts. Sorry. So if I turn on the power here, the output voltage will go to 46 or 47 volts. You can see that the oscillator here is running at 10 kilohertz and the output voltage is 46. I'm going to now put the load on it. Now I've hooked up the heater, which is this glue gun, and we'll turn the power back on. Okay, with the load on, I've got 38.9 volts on the output of the charge pump, and I'm going to turn off the power and measure the resistance of the load when it's hot. So it's about 200 ohms and climbing rapidly as it cools off. So it's now 220, 230, and remember it started off at around 500 ohms. So it goes down with temperature, and it looks like it gets under 200 ohms when it's fully heated up. That's a bit more load than I wanted, but so this is the multi-layer ceramic charge pump, and you can see with no load it's the same voltage, 46.2. Just wait for that voltage to go down to something I can handle. There we go. Now we have the load hooked up. Let's see what it does. And it's only 36, 35, and dropping as it heats up. So as the load becomes bigger, it can't pump enough charge to keep the voltage up. So the voltage is down at 34. And I'm going to measure the resistance or of the heater. It won't be getting as hot because it's not as high a voltage here. It's only 33.9 right now. But I'll let it warm up for a little bit to see just how hot it's going to get. It seems to be stabilizing here at somewhere around 33.8-ish. Still going down though. Okay, it seems to have stabilized, so let's measure the resistance. Voltage is down to 0. Resistance is climbing again at 220. So it was about 10 ohms or so higher in impedance because it didn't get quite as hot. But it does explain why the voltage is drifting a little bit, because as the heater heats up, the resistance goes down, and the charge pump has a harder time delivering enough charge to keep the voltage up. One quick little test I need to show you is the performance as we increase the frequency. So we're starting out at 33.9 volts at 20 kilohertz, and I can adjust using this pot the frequency. So if I take it up to 25, you can see it's up to 35 volts. If we take the frequency up to 30 kilohertz, it's already up to 37 volts. So as we increase the frequency, we can transfer more charge because there's actually more cycles to transfer charge. And the more charge gives us a higher voltage because it's a higher current through the same resistance. So at 46, 47, 50 kilohertz up to 39 volts. And you can see the ripple is reducing up here. So 70 kilohertz, it's at 40 volts. Whoa, we have a visitor. And if I go up to 144 kilohertz, it's still at 39. So it does make a difference if I increase the frequency. And of course this happens with both types of capacitor, but the multi-layer ceramic benefits more because it's actually operating at a lower capacitance than the polymer caps at these voltages. So just taking it back down to 20 kilohertz here. And we can see the voltage is dropping off again. So that's a quick demonstration of the performance versus frequency.